Hello everyone, it's September 19th. Alright, let's do this. Implement router. A data structure that can efficiently manage data packets in a network router. Each data packet consists of the following attributes: source, destination, timestamp. Implement a router class. Router memory limit. Initialize the router object with a fixed memory limit. Memory limit is the maximum number of packets the router can store at any given time. If adding a new packet would exceed its limit, the oldest packet must be removed to free up space. Add a packet with a given attribute: source, destination, time. Timestamp. What's timestamp? The time at which packet arrive at the router. Okay, so it's gonna be a priority queue on timestamp. So it's a min heap on timestamp. A packet is considered a duplicate of another packet with the same source, destination, and timestamp already exists in the router. So all three. Dude, all three. Return true if the packet is successfully added. Otherwise, return false. Forward packet. Forwards the next packet in FIFO order. Remove the packet from storage. Return the packet as an array. If there are no packet, return empty array. FIFO based on what? Based on timestamp. If there are no get count returns the number of packets currently stored in the router that have the specified destination and have timestamp in the inclusive range. Holy shoot. God lord. Okay, that time range means it has to be a binary search, so we have to sort them. Oh. Note that queries for add packets will be made in increasing order. Okay, so we don't have to sort them because add packets, the time will have to increase, or at least not decrease. Right? You can see the example here. We have 3, and then we add. But let's say the oldest packet. I think the oldest packet is the first one that comes in. So it's a queue, right? So oldest packet, I think this one is gone. Add, that's a duplicate, so return false. Add, the oldest is gone. So we have 2590, 3595, and this. Forward, so 2590 is gone. Add, count 100 to 110. Oh, with destination. Oh my goodness. Okay, so add. It's we can do a queue. Deck. We'll do a deck. We'll do a deck with restricted size, and as it comes in, I can do that. Okay, that's fine. And then we need to handle add packet and forward packet. Forward packet is just to take the top, so that's not difficult. Take the front, right? That's okay. We can do that because forward packet doesn't really have anything special. Add packet is also add packets needs to check. Now they are all integers, right? They're all integers. So pair. Can we do a set on pair? Can I do a set on pair? Maybe. I'm trying to see if there's another way to do this. I don't think map is a good way. And they don't really, 10 to the 5th is that. This 10 to the 5th. Timestamp is 10 to the 9th. So we probably need to use a set. But I'm not sure. In C++, can I use can pair, right? Can std pair be used in an unordered set? No. So we have to provide our own hash function. Oh, okay. That's probably not what I want. Oh, set. Oh, set can do. Unordered set cannot do. Set can do. Okay, can std set handle pair int. It doesn't really matter, does it? Yes, it can handle. Okay, so I'll use a set then. I use a set. So every packet we'll put in set. But how do we know? Can we check if it exists? How do I check if an element already exists? I mean, it can technically just insert and then check the size. If the size doesn't change, that means it's you don't have to worry about it. Okay, I guess that can do. That will do. So we have a set, we have a deck. So set handles add packet, deck handle add packet. Forward is deck, have the forward, and the set has to remove as well. All right, what's the API for remove? How to remove? Erase, I guess. Remove an element from set. Erase. Okay, so we'll erase it. What else? Get count. See, get count can be tricky because get count requires a destination, so we need a destination. So okay, so we have a map with destination. All right, we have a map with destination. See, that's the thing. You have a map with destination, and then you put what? Put timestamp in it, right? So it's going to be an array. But then you have to like update this, right? You have to update this thing. Like you have to remove it or pop it. So, well, I mean, since we're always doing it following the time timestamp, so it's going to be a deck as well. Huh. Duplicate. What if we just go destination? But destination, because these timestamp always increases. So if I have, like, yeah, in this case, I have a 490 and I have another 490. I already see 4 has a 90. Ooh, but we can do source, right? That's when we can have I don't even think this one is allowed. Oh Lord. Just to see if it's a lot. My bad. It should be this. Yeah, it does allow. Right, I have a 2, 4. So it can. So in this case, you don't know. Madre mia. You don't know. Have to specify destination. So the only thing that's tough is, I mean, I can put, and this is the destination, and we do, this is the source, and this is the timestamp, and this is going to be a deck. We put them in there, so it's always going to be sorted, and every time a new one comes in, all right, a new one comes in, I always check. You can't always check, because in this case I can have 1 490, 2 490, 3 490, 4 490, 5 4, I can do all of them, right? And then I have a duplicate comes in. You never know. You have to search through the entire thing. That is not possible. Okay, that is not possible. So the duplicates, we have to use a set to handle. But the packet side, we can use this, right? We can use this map, as I can map it and push it in. It's guaranteed that it's sorted by timestamp increasing. But what we don't know is no, we do because it follows the destination. It follows. So forward packet. So we want to know who is at the front. So we need a overall. We need an overall deck. So we need an overall deck. Right? We need an overall deck. We need a overall set, and we need a destination map. We need all three things. This one tells us which one to pop, right? And then we can go in there and then pop the front as well, because they should match, right? They should match. And this set tells us whether it's a duplicate, and this map will help us to count. So we go there, we have this. Then we just need to do a binary search. Now, here is the thing. Do I need to add source here? Why do you need a source here? You don't, because you said every time you're going to pop on the deck, you're always going to find the first timestamp here as well. So you don't really need the source. So it could be just an array of timestamp. It does not matter. It does not matter. Okay, so that's kind of the strategy. Let's give this a roll. All right, so we need a deck of pair let's do this source destination. Okay, std pair source destination and then timestamp. So this is overall deck set make them the same. Overall set this is a destination map. Destination timestamp map. Oh, that's not right. This has to be a deck. Can I do binary search on the deck? Can I use lower bound and upper bound on deck? I guess you can, because it should be a container. Yes, you can. It's an iterator, right? All right, memory limit. Memory limit. Int memory limit. That's it. We don't have to do anything else. Let's add packet. So previous set size equal to overall set dot size, and then we say overall set dot it's fine, or set dot insert source destination timestamp. Okay, if overall set dot size is larger, first things first, if there are several things we need to consider. All right, damn it, pair all right, so we call it, this is P, packet. All right, so source destination and timestamp. Okay, then we have to say if it is init, then it doesn't matter. Actually, I think we have to say if overall set dot contains packet, right? If it contains the packet, then we'll just return false because it's already in there. Otherwise, if it does not contain the packet, then we need to add it. But it depends on if we can add it. We should say if overall deck.size is already equal to memory limit. So we need to remove, right? So we need to have a function called void pop packet. So this is remove the oldest. That's not true. Oh, it is just forward packet, right? It is just forward packet. Yes, this is just forward packet. We remove a packet. And then if it's already, we remove a packet. And then we add one. How do we add one? Overall set.add, no, insert packet. That's fine, we can do a copy. And I'm okay with it. And then, yeah, that's all right. Overall deck dot insert packet. Dear me. All right, so both insert packet, and we have to have the map. All right, dest map. Destination. All right, dot push back timestamp packet. Oh, there's no insert. Pushback. And I'll return true. Alright, this is going to be difficult. So we're gonna forward. So we're gonna pop it first. So we say auto packet shall equal to overall deck dot front, and overall deck dot pop front. Right, pop front. Then what? Then we need to remove it. Overall set dot erase packet. Okay. Now what? Now dest ts map packet oh my goodness, packet dot first dot second, that's destination, and we do a deck dot also pop front if that's okay. We don't use that for checking, and they didn't say if it will call. We can actually try get count. Let's say it should give you a no count. A zero count. So maybe we should remove it. Alright, so if dest ts map packet dot first dot second dot empty. Then the dest ts dot map dot erase packet dot first dot second. All right, so this is done. Now I return packet dot first packet second. No, okay, that's fine, but here is dot first, right, packet dot first dot second, and this. Good. All right, this is the last piece. So we need to go to destination and say auto const auto deck is if dest ts map dot contains destination. If it does not contain destination, we'll return a 0. Otherwise, this will be destination ts map destination. Okay. I'm gonna say auto left is lower bound. Oh, is this with inclusive? So lower bound is the first one. That's, I actually forgot. I think lower bound is the first one that is not. Actually, I forgot. What is lower bound again? What is lower bound and upper bound? I think lower bound is the first one that's not smaller than it. Upper bound is the first one that's larger than it. Yeah, lower bound is the first one is not less. Upper bound is the first one that is strictly greater. Yeah, so left, it should be fine. We can do deck.begin, deck.end, and start time. All right, this is gonna auto right shall equal to upper bound. Right, deck.begin, deck.end, end time. Strictly larger, right? Strictly larger is the first that's and the difference between the two, right? So we can just return left or right minus left, or if we want to be fancy, distance left and right. All right, so give this a shot. The time might not be, because I think I did a lot of copy. There's a lot of copy going on. Hey, what the hell? Forward and forward. Oh, I did not consider. If overall deck.empty, right? So nothing to forward, so return this. Yeah, this is something I missed. I don't know. Depends on how fast it goes. I guess it's alright. I guess it's alright. What the hell? I forgot even to write that. 3508. Just implement it as described. Using a deck, a set, and a map from destination from integer to deck. Not too much to say. I think it is likely that had we been a little bit more imaginative, we might be able to. Actually, I'm not sure. What do you think you can improve in this case? Well, we are making lots of copies. Once you push it in, you have to make a copy, right? You have to create one and then make a copy. But the other one, maybe we can just use reference. Dangerous. Too dangerous. Don't think that's actually a right strategy though. When was this first published? 2025 April. I was in the contest. Alright, we got it done. Yeah, let's call it a day. Time to watch Akibasho. It's the 5th day of Akibasho. 15 days of this to watch. Actually quite exciting. Alright, I'll see you guys tomorrow.